Thank you. So, who has been in this situation? That it's DNS, TLS, or bad configs? That's a surprisingly low number of hands, because normally if something goes wrong, it's one of those three that break your back. And how I always remember is that those of you who have seen Harry Potter is when McGonagall asks, like, why is it always the three of you that when something happens, you're there? And that's exactly DNS, TLS, and configs. I think it's like in Harry Potter that if something goes wrong, they're there. Starting with DNS, I don't want to say it's like the brains of what we do, but oftentimes it's kind of like what keeps everything together and more or less sane. So I picked Hermione for that. So DNS is when everything normally goes wrong. My personal story is when I reconfigured some DNS servers and I copied the wrong server for some domains, and then you can just watch them disappear if you have a long enough time to live. And then you can do nothing and can just wait and wait until it comes back. TLS is always one of these things that is always sitting somewhere and just wants to jump at you at the worst possible moment if some TLS certificate expires or you configure it wrongly. And some companies are more prone to misconfiguring that than others. So for example, Microsoft has had multiple incidents, or Azure had multiple incidents where their entire service went down because some TLS certificate deep inside their infrastructure expired, which is like a super stupid problem to have as a big infrastructure company. And then finally, bad configurations are always kind of like the end boss, or it's like oftentimes when something changes and nothing works anymore, it was a bad configuration that you applied. Maybe you remember the Facebook outage a year ago, that was a bad configuration. I picked a different one earlier this year. There was a Cloudflare outage, which they tried to do to make their project more resilient, and that took down most of their project, just because there was some configuration that they hadn't quite planned out as it should have happened. So I tried to call these three like the Horcruxes of IT or operations. It's always DNS, TLS, and bad configs. And then the question is, how do we fight the Horcruxes? What did we do? So my take is that, okay, we don't have the tooth to stab stuff, but my take is that with health checks, we could figure out a lot of the things that are going wrong. So the health checks that I want to look at is how can I ping or kind of like check if something is running the way it should be, just to figure out our problems quickly. So we could ping from outside the network, and on the host itself. And depending on what you see, what is working, what is slow, what is broken, you could figure out different things where they are broken. So my take is you're on one provider, you ping from another provider, you can figure out like, is DNS working? Is the uplink of the provider up? Did you configure the firewall correctly? Is the load balancer there? Is your service available in general? Within the network, you could figure out like, is the network between availability zones, for example, there? Did you misconfigure the firewall? So here you can reach it, but from the outside you cannot. Maybe you configured the outgoing firewall wrong. TLS you could put wherever you want. And then on the instance, for example, you could check if you have a load balancer or proxy. Is the load balancer or proxy down, or is the service actually down? So depending on where you ping, you could figure it out, or you could figure out like, is my database reachable? Did I misconfigure the firewall on the database or not? Just as an example to how you could schedule some health checks. How long is the first one? Who likes the cron notation? Every 5 minutes. And then you have like pinging a database or an HTTP service, or you could do something a bit more elaborate where you actually run through an operation to say like, I want to add something to my service and want to send this request, and then a 200 comes back just to see if my service is actually working the way it is supposed to be. You can move that a bit further to something that is called synthetics, or some people say like they have been doing something like that for a long time, they just never called it synthetics. It's pretty much simulating a user in a headless browser. Playwright is a very common tool to actually do that. It's basically scripting a common flow so that you can figure out, I don't know, you have a web shop, you put something in a basket and you do a checkout. It's what your users normally do. So you figure out that your site is broken before your users do. So here I'm trying something to, I don't know, I'm loading the page and see what's happening. And that could be the result where you say, do I have a sign up button? How quickly does the page load? Where do I spend my time? Is TLS working? How long does it take to do a TLS handshake? What is all this weight on my page? And that hopefully gives you an idea why it's always these three things that fail, and also how to fix that. And before I run off, I normally try to take a picture with you so I can prove to my boss that I've been working today. Hold tight.
So, hi everyone. First I want to say it's a pleasure to be here in beautiful Porto, and welcome to my talk about technical documentation, how to write it better, and why should I care. So I'll start by introducing myself. My name is Naomi Kriger. I'm a software engineer, and a part of what I do is conducting technical writing workshops for engineers, researchers, DevOps, and many more. I'm also a technical blogger at Medium. I used to work as a content writer, and I'm a co-leader of a community for junior engineers and researchers. So now I want to ask you, why should we engage with technical writing? And my answer for that is to save the world, of course. Whether we want to improve onboarding, help with system handover, make engineers more independent, and simply assist everyone around us. However, I do want to ask you, why should you devote your time for it? And there are many reasons for that, such as to learn by teaching, to improve your communication skills, to improve your visibility within the organization or the community, and many other reasons I just couldn't squeeze into one slide. So let's say that I convinced you. You want to join me and start writing, and then you would probably ask me how to get started. So today we will discuss content, structure, feedback, and the secret sauce of getting into writing, which is having a non-killer draft. And by non-killer draft, I really mean do not chase perfection. So even if this is not your mother tongue, you're not keen with the technical details, and you're not sure that what you wrote is clear or coherent, it will get better as you revise your doc. So now the first thing you want to keep in mind when you start writing is our audience. So ask yourself, what are they expected to know, and are there any prerequisites they should be familiar with before reading what you wrote? In such cases, I suggest to add links for further reading or watching before they read your documentation. Next, we have definitions, and here I suggest we add a definition for the topic or the system that we're documenting, and that we make sure the definition is clear and concise. Now, the next thing we want to keep in mind when you start writing is asking yourself what to include. So the way I like to look at it is by asking myself, if I were writing a book, which chapters must be included in that book for my doc to be clear for a newcomer who has a reasonable background? And then the next question would be what to omit. And here my suggestion is anything that is not directly related to your topic. In such cases, I suggest to either remove such content completely or replace it with a link for further reading. And then I want to talk about the length, because a doc that is too long is simply intimidating. So for each sentence and paragraph in your doc, I suggest you ask yourself if it's really necessary, and if not, to cut off what you can. However, cutting off sentences should not be at the expense of content clarity. So for each, we will talk about feedback later, but until then, I suggest that you reread your doc and ask yourself if it's clear for you, and if you expect it to be clear for somebody else. And now, the next thing I want to talk about is structure. Here, I suggest you add headers, paragraphs, and table of contents to help those who want to read your doc through, or to skim over it in order to find specific answers for specific questions they may have. Another thing you can do in order to make your text more structured is to use bullet lists and comparison tables. These will help you to make your text more concise and will also improve the readability of what you wrote. And now the next thing is architecture sketches. And here, I suggest that you make sure that you explain yourself. For example, use a title in order to describe your sketch, and use a legend in order to show which components are represented by the different icons. Also, regarding architecture sketches, I suggest to use colors. Colors could really make all the difference. So use colors in order to distinguish between the different components, and also to indicate statuses, such as success and failure. And now the next thing I want to talk about is code snippets. Code snippets is a great way to convey a message. So if your snippet is not too long, I suggest to embed it within your doc. And if it is too long, I suggest to replace it with a link to GitHub. And now the next thing I want to talk about is feedback. Feedback is the most important part in practically anything we do in life. So just like your code wouldn't make it to production without receiving code review, I suggest your documentation will always go through at least one iteration of proper feedback. So now we're all ready, and you are specifically ready to start writing. And remember, we always start small, and we improve our documentation through iterations of feedback and revisions. So thank you all for listening. I really hope you enjoyed the talk, and feel free to keep in touch. You have here links to my profiles. My LinkedIn profile, my blog on Medium, where I write about technical topics and career-related topics, and my handle on Twitter. So thanks a lot, and muito obrigada a todos.
So this is actually the first time I'm giving a talk like this, and I'm not as good as the other presenters, so I have some notes over here. And if I mess up, please still clap, so I don't feel bad about myself. So yep, I really like serverless. I started my career in a serverless monitoring product, and I've seen serverless come up in a lot of places. And today I want to actually present to you 5 use cases where I've seen it come up, and how it really helps with the concepts of DevOps, like you build it and you run it and you automate everything. And you know, the reasons why I really like serverless is because one of 3 major properties, it's fully managed, it's scalable, and it's pay-as-you-go. And I feel that this is what helps us make cost-effective DevOps solutions, or at least maintain availability and resilience in our systems when it's you know, at an effective cost. So the first thing I want to get into is performance monitoring, and this is actually something that we used to do in my old company in Opsgenie at Atlassian. And what we used to do is we used to have like all of these Lambda functions, and what we would do is like we would impersonate users with these Lambda functions, and we would use a monitoring tool like Datadog to check whether, you know, what the response of these Lambda functions are. And so it was basically synthetic tests. And then what we would do is we would, again, use our own tool, Opsgenie, to send the alerts if something went wrong, and then you basically ping on-call responders. So basically, like, you know, continuously ping and impersonate users, and if something goes wrong, pull in on-call responders to make sure that we respond quickly. And you know, and talking about, like, you know, ping on call, I actually want to talk about EventBridge, which is actually my favorite serverless service from AWS, and how we can use it for automated mitigation. So imagine we are monitoring a bunch of stuff with, again, any monitoring tool. I work in Datadog, so therefore the Datadog logo. But and then, like, with using the EventBridge integration and the EventBridge rules, you can then perform actions against your infrastructure, and even call upon serverless functions to perform those actions. You know, so this is like some form of automated mitigation. And then talking about automation, I want to talk about a scary use case of automation, which is basically GitOps, which is basically automated continuous delivery. And this is pretty scary, because what is happening is that whenever a pull request is created, Docker images are pulled into the registry, and Helm charts are stored in S3 buckets. And then you have a Lambda function which can basically pull in these Helm charts and commit them. And then what we can do is we can use we can use tools like Weaveworks to continuously monitor these changes in our cluster repo, and then perform those changes and manage those changes in our Kubernetes clusters. And this is actually a very, it's a very exciting use case, but it's also actually very dangerous, because you're performing these changes automatically, like as soon as the PR is created. And so when you are doing these changes and you are continuously pushing changes automatically, what you would really like to do is do some CI load testing. And again, here we can use the scalable functionality of Lambda functions, where you set a baseline. You're constantly impersonating users again against your infrastructure. You're running, and what we're doing over here is we're running Postman scripts to run these Lambda functions, and then we scale our Lambda functions, and then we use a monitoring tool. And again, I work at Datadog, ergo the Datadog logo, to monitor against our baseline SLOs. So we set our baseline SLOs. We had and then we scale the tests, and then we see if our SLOs are degrading. And one of the last use cases I want to talk about is actually SecOps use case. Because DevSecOps is really trending right now. And in security use cases, for example, like blocking malicious IPs, you can't automatically block IPs, right? So you can't really automate this. But what you would like to do is you would like to pull in responders, and then have those responders investigate and collaborate, and then, damn it, I missed the slide. But basically, you would like to get responders in, and you would like to have investigation, and then respond on Slack. So basically chat ops. But you know, serverless is just not these ancillary tools. Like in a longer talk and a more proper and prepared talk that I give, I actually talk about how we can build serverless architectures for active-active multi-region systems. Many of you may have seen such talks. You know, we talk about event-driven microservice architectures, and of course, with serverless, one of the greatest things is that it's cost-saving because you pay as you go, right? Not when you scale, though. When you scale, it can become very expensive. And so what I really want to say is that, you know, we saw these 5 use cases that I really like and I've seen all around, and I hope you have been inspired by them. But yeah, but you can also use serverless for other stuff. Thank you so much. I know I missed a bit slides, but next time I'll be better. So.
Hello everyone, good afternoon first of all, and today I will present how to break the script using the OpenTelemetry. First of all, who is familiar with OpenTelemetry? Oh, yeah, it's a pretty huge audience. So basically, OpenTelemetry consists of receiver, exporters, batches, processors configured in order to get the data flow transmitted from the source to Prometheus or monitoring tool. One of the main advantages of the OpenTelemetry is the OTLP, the OpenTelemetry protocol that standardized the data flow. Sorry, this is my first time here. And basically, we have this draft or this workflow explaining how the OpenTelemetry works. We have on the left side, many source transmitting data, to the to the receivers, and basically the configuration consists of config map defining the receivers, processors, exporters, and services. And let's talk about what are receivers, processors, or exporters. The receivers, we have many different ones, Jaeger, Kafka, Prometheus itself, which will transmit data through the OpenTelemetry onto the exporters. In the middle of this, I would say this calls, we have these processors that you can configure how the data will be transmitted, and then you can configure the metrics, the batch, how the memory will be limited, and also you have many different exporters which can be push or pull based, like Jaeger again, the Zipkin, or file path itself. In order to get further receiver or exporters, you can check this OpenTelemetry contrib repo. You're gonna find many different options to configure your application or your OpenTelemetry collector. So let's enjoy what the monitoring tools have to offer. Like Datadog, Dynatrace, Grafana Cloud, we have all of this, but if we put the OpenTelemetry in front of those monitoring tools, because with that approach, doesn't matter if we have a Node.js or a Python application, we're going to avoid a lock-in into those monitoring tools. And then, in order to get our OpenTelemetry collector configured, should we use the operator approach? Yes. Because the operator will handle the state of your collector instance, storing your processor or receive configuration. This is the target allocator. This is a situation when you have OpenTelemetry for many Prometheus targets. Probably this is a cause at the first look, but we can configure the OpenTelemetry operator as a stateful set mode. In the case, you can configure each stateful set instance for a specific target. And then imagine that you have 5 different targets, you have a stateful set configured, then you can point one stateful set for each target. Okay, the OpenTelemetry operator also offers an auto-instrumentation, because you sometimes on your development team you have some technical debts, and you can avoid
Mm-hmm.
investing time instrumenting your application, you can configure the auto instrumentation for different languages or programming languages. Basically, you have to create a customer resource called the OpenTelemetry collector with a sidecar mode configured and annotate your application with those instrumentation. Okay, in the case of Node.js, you have to put an annotation called inject Node.js true, and then the collector will create a sidecar inside your pod application. This is a manifest of a customer resource looks like. You can you can list your instrumentation with this hotel list, and yeah, I guess that's it. Thank you.
Thank you. So as Sarjeel and Yuri, it's also my first time doing Ignite, so please be gentle. So this is a bit of a trap question, but for long you'll see why. So usually when you start working on a new project, you get that question, which is, should we start completely from a blank slate? Sorry, before that, getting myself. So I've been around here a while. I'm not a veteran or a guru or whatever, but I work in very different areas, so as everybody, we've seen a few things. So when you work on a new project, sometimes you start with a brand new platform, blank slate, you can do whatever you want. Other times, or you can think about evolving an existing platform or system. The thing is, which approach should you pick? It's always a bit of a loaded question, and unfortunately, the answer is kind of that ever unsatisfactory answer, which is correct. It depends. It's the answer we really like to give, but we hate receiving. And it's easy to understand why, because there's always way too many variables to give like a straight answer to something like this. And usually when you're maintaining something, usually you know the system, hopefully it's stable, again, hopefully, you know how it ticks, you know how it works, you know how it breaks. That's also very important. But on the other hand, when you're working on that big, shiny new stuff, it's always cool because it's new technology, everybody loves that. And also, sometimes you just have to because of obsolete technologies, sometimes it's new constraints, new requirements, so sometimes it's not even a choice. And the thing is, why it's a trap, because honestly, most of the time it doesn't really matter. What matters is how we actually do it. As long as you go, you find some patterns, sometimes you probably also fell into them, some stuff you shouldn't do. And keep in mind that this isn't really that new or groundbreaking. It's just some patterns and things you happen, and you see it, and it happen over and over again, even though we all should know better. And stuff like, for example, when you start to do the greenfield, meaning like a blank slate, you can decide whatever you want, you can pick whatever tools you want. And on the other side, have a brownfield, which is have existing technologies and processes you need to work around them and adapt to them. But the thing is, greenfields are great, but if you don't tend to them, they become a swamp really, really fast. And sometimes even before reaching production, you're already, because of timelines and pressure and taking shortcuts, it all goes to hell really, really fast. Also, always plan for the decommission of the old stuff. We always think about it, but usually we push it as an afterthought. And it's a technical problem, it's also a management problem and a political problem, because you need to involve a lot of people. And you don't want to maintain 2 or 3 versions of the same platform or system. Ask me how I know about it. So really kill them, because they will come back to haunt you, whether you like it or not. And I've seen way too many kill X projects in my time that go on for literally years. So avoid constant big changes in the sense of, okay, let's just throw it away and start from scratch after like 1 or 2 years, because you're losing stability, you're losing knowledge, and basically you're wasting all that accumulated experience. But if you do, try and maintain the interfaces or configuration files or whatever, because it's always difficult, especially as you scale to hundreds of services or whatever. It's really hard to burn any goodwill from your developers and users when you're constantly changing things and need to adapt yet again. And with this come migration to new platforms, new databases, whatever. This is always really painful. It should be as painless as possible and ideally even transparent. If they don't know it's changing, even better. I die inside a little bit every time I see they tell me to copy a 100 or 200 configuration file with YAML. Oh, just change these 2 variables and you're good. Why? If it's not needed, it should not be there. Please don't do this. On the topic of choosing technologies, can't go without mentioning Dan McKinley's talk, Choose Boring Technology, because new is not always better. It can be, but sometimes you should really go with what you know. There are tons of good reasons for that. And also, missed opportunity to suck up to charity majors, but this is also has some very good tips on making better decisions, because making good decisions is really, really hard. So I highly recommend this talk also. And yeah, that's about it. Feel free to agree, disagree. Your mileage may vary, and we all know there are no silver bullets. So hit me up. I'm always up for trading some war stories. Thank you.